This is a fretboard from a guitar, and pretty familiar to most people, and it also seems to be one of these hobbies that many people in the CAD industry have. I'm not sure if we all picked it up during lockdown, but anyway, lots of guitar stuff, all good. So a fretboard is characterized by these, obviously the frets, and the interesting pattern that is in here, which is a decreasing distance. Really interesting series, right? And you calculate the decreasing length between them according to some interesting math, right? Now you can go into that, and if you really want to just jump straight to it, the distance between the nut and the ith fret in the series is this equation up here. So you have something called the scale length, and the scale length is the total length of the string, right? So it goes from what they call a nut here towards the bridge, which is kind of off the screen down there. So the equation is like scale length minus scale length divided by 2 to the power of the I divided by 12. Now 12 is a very important number in music because it is the 12 half tones between an octave. All right, so these frets here go up to the 12th fret, which is marked in red, and that is exactly half the length of the string. So half the scale length, if you were. Right, so that equation is an interesting one on its own right, and I encourage people to check that out. But how do you do that in Onshape? Well, that is what we're going to do today. So I'm going to hide a few things and take you through the process I used to create this. So let's go back to here, and I'll just talk you through some of these first simple early features. I created a couple of sketches, and I'm going to highlight them in blue because that's what you should do too. So I lofted this, that between those twos, and then I drafted it to provide sort of some taper. Now I could have done that taper as part of a loft by creating different size profiles, but I wanted to play a trick and show you why I did that separately. So if I do a loft between two equal sections, I could have done an extrude as well. Right, I could have done a sweep. There's many ways to do this. Anyhow, I did that, and what we end up with is a cylindrical face up the top there. And a cylindrical face is perfect for applying a decal to. So I've got a decal which is a nice looking kind of rosewood or something. I don't know. I think that's what we use. Anyway, which you can do. Now, the trick is that after you've applied the decal onto a cylindrical surface, even if you do a draft, it still sits there. Now, this is no longer a cylindrical surface, of course, but the decal doesn't know that because the decal was applied to a cylindrical surface. Anyway, it's this nice little trick. Now, it's not something to be abused, and you wouldn't do this with very drastic UV mapping changes. Anyway, but for something like this, there's no engineering to this picture in the background. It looks nicer. Anyway, onwards. I created a curve which is going to represent where the nut is. Now the nut is sort of basically the start of the string. Now the string wraps over the nut, but basically it's the start of the vibrating portion of the string. All right, and then I did a sketch on that. Oops, this perspective mode's a little fast for me. Normally I'm in non-orthogonal mode. Anyway, so there's a sketch in the middle, and you're wondering where that sketch plane was. Now I often use a mate connector as the sketch plane, and you can do a mate connector very easily now, which is lined up with curves. So yeah, go for it. Don't worry about creating extra planes when you don't need to. Just go with a mate connector. And of course the intersection curve was the intersection between a plane, which was this plane here, and the top of the fingerboard, or the fretboard there. Anyway, so that was the plane for the nut, and then of course I swept something down that section through there, got a couple of champs on it, and then I did a trick, because you can see here, because of the way that the sweep worked from that center line, some of it is embedded underneath here. So I did a move face to bring it out. I'm going to turn orthogonal off because my mouse is super quick today. I've been doing something with my mouse and it's come out of config. Anyway, that is the move face, which is on both sides like that. And in fact, this is how you'd construct it, and then you'd file this off later on. But anyway, let's do the Boolean. Let's cut the let's see, I've cut that trench out. This is where you'd put the fret, and then I'm going to replace the faces of this with basically this side face here. So this face now is the same as that face there, and the same on the other side. This is kind of equivalent of filing it off smooth, which you'd want to do so you don't cut yourself. That's the easy bit. We've got the nut. And then the interesting stuff comes. So as always, and what you're going to definitely need to do here is start getting your variables going. All right, so I've got a couple of variables here, and one of them that I did use at the beginning was the fingerboard length. Now the fingerboard length, I just went and measured my guitar behind me here. We used that to create the initial loft, or the initial, at least the planes where the fretboard would end. There's the variable there. Big tip is that you should put the variables right next to the features, the first feature that uses it. Sometimes you think you want to put all the variables up the top, but of course it's more efficient if you use the variables, only put them in where you're going to use them. So you save some unnecessary regeneration if you do it this way. Anyway, because you've got the variable table over here to sort things out and have things nice and neatly and put your notes in anyway. So this is the best way to do it. Right, so I've got a couple... actually, let me go back with this variable. It is possible to use that variable when we applied the decal. In fact, that's what I did. For the automatic width of the image, I actually provided the fingerboard length plus 10, which was the allocation for the nut. So the image will maintain its aspect ratio and automatically wrap to the entire face here, even if I went back and changed this fingerboard length. So that's pretty cool as well. All right, so the next ones are really important. I've got a variable which is going to be the number of frets, and this does vary between guitars and brands and things. And then the all-important scale length. Now, as I said before, the scale length is the length of the string all the way to the bridge, which is kind of down here, not drawn. So we need to know the scale length. So as a variable, this isn't going to, actually it's a constant to be more correct here. So is the, but, all right. The next variable we have to define is going to be called I. Now, I is going to be a loop. And if any of you are familiar with programming, one of the most common patterns is a for loop, where you say for I equals 0 to 22, and then you execute a lot of code inside the curly brackets, depending on what you're using, JavaScript, whatever. Anyway, you execute all of that block of code where you can use the I, which is use incrementing from 0 to something. Now, we can do the exact same thing in the feature tree, and this is not using custom features or anything. We're just going straight normal Onshape here. So the trick is that you define the variable I equals, and sort of initialize it at I equals 0. Now, the next one, which is non-intuitive, but I tell you it's going to be a great thing for when you work out this and get to use it yourself. You redefine I, but you say I equals, and then you use the same I, hash I, plus 1. So this is the first loop. So this is I equals I plus 1. So that is sort of the blindingly cool moment that you've been waiting for, because now we can continue doing some features. Now, the next feature really is, if you remember back to here, we had this where I is going to iterate over the number of frets that we've got. So I equals 1 first fret through to the 22nd fret as per the definition of how many frets we've got. So we're going to implement that equation exactly as written, basically. Scale length, which is a variable, minus scale length, divided by 2 to the power of hash I divided by 12. So that's exactly just basically cut and paste and put a couple of hashes in there to create this. Now you'll see that this offset is a single number, and it's evaluated with I equals 1. So this is the offset for the distance from the nut to the first fret. That's a very useful number to have now, because we're going to use it to create a plane. This plane is going to be located, I'll just go top view. This is going to be located obviously where the first fret is, and if I edit the plane, you'll see that I've just used offset from the nut plane, and I've used the variable that we've just calculated down here, over here, sorry. Right, so that's easy enough. And then there's the next few features are pretty easy as well. I've just, again, done an intersection curve between this plane we created and the top of the fingerboard. Now that's easy. Now, just for interest, I've used a different feature now. Instead of moving face, I'm going to do a trim curve, or a trim and extend. So you can see here, I'm extending that curve just a little bit using this operation called trim curve. I've just given it just the slightest amount. I could have put any number in here. This is not really significant, other than it just needs to be outside the edge. Trim curve is over here under the trim curve feature in the tool set of curves, and you can either trim or extend. So I'm using the extend method inside this feature. Once we've done this, I am going to give myself some more room so you can see. Right, once we've done that, I'm going to put a mate connector just so that you can see that I love using mate connectors to act as the sketching plane for this. Now, this time I did remember. You can see here, sketches are so much nicer when you give them color. Like blue, primary sketches are primary blue in my own mind. So you see here this used this mate connector 1, which was the one we defined here, as the sketch plane. Again, no planes unnecessarily created here. And the good thing is that because this is lined up, when you create a mate connector, actually let me show you an example on the other end. When we create a mate connector, when you select a curved entity, you'll see that it snaps now nicely so that it's aligned along the tangent of that curve. So this could be, a spline, a Bezier curve, or some projection, or whatever, straight line. Doesn't matter. It also means it's going to parametrically update, so that's good too. It's necessary, all right? So once we've got that, we can obviously do a sweep, and you can see here I've used a nice profile, or a simplified fret profile. This is the fret wire that you would buy off the shelf, cut it to length, glue it in like this. Actually, you'd saw in, you'd do what we did before, which is to cut this trench first, and then just use the transparency here, and then glue the fret in. And in this case, I've left it overhanging a little bit. I could use the replace face trick, and maybe we can come back and look at that. So all of that talking, has resulted in one fret, the first fret, and it's that distance 36.353. Now, if you want to double check my work, there's a million different fret calculators out there. And here's one from a retailer. And they've got a really nice explanation about it, blah, blah, blah. And, I've put in a scale length and number of frets, and, nice use of configuration here. We'll do that ourselves later. But you can see a 36.353 is the first position for fret number 1. Okay, so that's good. We can do it again. everybody gets the right. I mean, it's pretty simple math, really, but it's good to get validation sometimes. So this is all good, and if you remember, we're basically in a loop. We're going to be doing a loop of those features. The I equals I plus 1, the offset which used the I, the plane which used the offset, and so on and so on and so forth. And the way that we can close a loop is with a linear pattern. Now this is, again, a little bit non-intuitive, but let's have a look at what happens when I unsuppress this linear pattern. Well, that's what happens. And that's exactly what we wanted. I have colored the 12th fret, but we'll get back to that later on. So let's have a look in this linear pattern, and I'll show you that it contained all of the same goodness of make connectors, planes. Basically, we've patterned everything in that loop, but we've done it in an extremely special way. Firstly, we've chosen a linear pattern, and it's a feature pattern, not a part pattern or a face pattern, but a feature pattern. And all I do is I select all of those that would be in that curly bracket loop of the I equals, variable var I equals 0 to something something and I equals I plus 1. That is the loop that we want. So we just choose all of those features in here. You can see it starts with I equals that one there and goes all the way down to the Boolean, and you can see it highlighted there as well. Next important thing is that we don't need any distance. We're going to set that to 0, because if you think about it, we are actually calculating the position of everything ourselves, and the sketches and the planes or the intersections are all based on that rather than any particular patterning increment. We do need to use our number of frets, which is this thing that we defined earlier. Right, so the number of frets is the number of instances we want. We do need that as the variable, hash num frets. And the last most important thing is the reapply features. It's going to reevaluate the topology as it does this and regenerate those features. That is it. All right, and if I hide the contents of the pattern, clean that up a little bit, we have what is basically our most of our fretboard. Now, obviously, this is going to connect to something like a neck and the rest of the guitar, but this is the hard stuff done, surely. Was I going to say anything else about this? Oh, yeah. So, if you really want to check, you could bring back the nut plane right there, and look at this is the distance between the 12th fret and the nut, and this is going to be exactly half of that scale length. So if you can do the math quickly in your head, you should be able to get that. 323.85 is half of this. That is cool. Now, this is only good if we can demonstrate that there's parametric updates and it's robust and all of those good things like that. So I have created some configurations. The first thing is the configuration of the guitar styles. Now the guitar styles, whether it's a Fender, Gibson, Paul Reed Smith, all of those things like that, they have different scale lengths. Now the scale length is very, very important to the kind of sound you get from a guitar, and it can explain a lot between the Fender, this is just like a Stratocaster length, and a Gibson, which is actually 24 and 9/16 inch. So there's quite a bit of difference in the string, and anyone who knows about guitars will tell you there's a lot of difference in the sound too. A lot of it is due to this scale length business. Basses have very long scales as well, so that's, anyway, won't go down that rabbit hole. But the good thing is that Onshape is so easy to configure. Basically, I've said I'm going to configure the scale length variable, and that's configured to be driven by this here. So I can very easily change to one of these Gibson styles, and it's going to regenerate things, and you'll probably see that the frets are now in different places. I'll go back again, back to where it was Fender, Gibson. Now they're actually a bit closer together, so they're different. You need to play them. You need to learn how to play them a little bit differently. Anyway, so that goes on. You can also change the number of frets. Now, most of these guitars have between 19 and 24 frets in this. So, that's obviously just changing one of our key variables here, which is, the number of times we would iterate this loop in our 4i loop here. So that's, not exactly rocket science, but it's really easy to create a nice configurable situation here in Onshape, and give them a nice name. So very good, very good. Now there is one extra rabbit hole to go down into, and that is, if I look up here, okay, there's some interesting things that you can get back to. And in the very, very old days, like in 16th century or something like that, when people were making lutes and other stuff, didn't have the benefit of Onshape, unfortunately, so there were some methods of creating approximate scales, and there was something called the rule of 18, because 18 was close enough to a magic number of 17.817, and you can do it. You can prove it to yourself with a compass, a sharp pencil, and a piece of paper. And basically, you draw the scale length as a line. You divide the scale length by 17.817, and do a radius of that, where it meets that. Anyway, that's it's an interesting way to do that. But anyway, that's not the rabbit hole I was going into. This one is. So fanned frets. Now, fanned frets are used on some guitars, and they've actually been used on stringed instruments, again, for centuries. But they're kind of cool, and you see them there's a pretty old one. You see them often on pretty radical heavy metal guitars. But there's a lot of interesting science and math behind this as well. So anyway, fanned frets are used when you have different scale lengths for each string. Now, in this previous example, here, I'm using a single scale length for all 6, 8, whatever strings on this instrument. But what if we used a different scale length on the treble side versus the bass side? That is interesting. So let me show you what happens when. I've given you given away the secret, or the final. It looks like this, and it's pretty cool. I'm looking down on it, and see here, this is the treble side, this is the bass, or the thicker strings, low strings. And these frets are basically fanned out. And at some point, it's kind of neutral, and then it keeps going the other way. Now, there's a few different things at play here. One of them is that the scale lengths for the low strings should be longer than the ones on the high strings. Now, there's a huge theories within that. That is, you want to keep the tension in the string similar across there. It feels better if you do that. They sound better through, that math that we were just glimpsed at there before. But they're also a little bit easier to play. Now, if you can imagine your hand grabbing around on this, your hand and your fingers tend to fan out. Well, if you like. And so it is a little bit easier to play these in theory. So some people like them, and they look really good. So how do you build it? Now, it's very, very similar to before, except you just add an extra variable. And I've actually used a configuration variable this time just to show you what that is. Now, if we go back to configurations, instead of just configuring input like we did with the Paul Reed Smith and Gibson and Fender, you go down here and say configuration variable, right? So that adds the input to something like scale length as what you can just type in a new value up here, and it reconfigures the Part Studio accordingly. Now, I've cleaned things up a little bit, because that's what you should keep always refactoring your Part Studios, and I've grouped things in the specifications section a little bit clean, and I've got a scale length for my low string, my high string, and a scale length for a low string here. And I think everything else is similar so far. I've done the same trick before. Now, there is something with these fan fret guitars that you need to be aware of, and that is that one of the frets is essentially neutral, or parallel to, or normal to the center line of the fretboard. And that is something that people will argue about which one of it should be. The 7th, 9th, and 12th seem to be the most common ones, especially 7 and 9, as being the most common ones to make neutral. You could actually make none of them neutral, and so you could put in 7.5 fret as being neutral, and then this would be around it. So there's a little bit of trickery that you want to do before we get into the same loop as before. Now, the loop from before actually is just, let's look at that first. Instead of having a straight line, of course, across here, I've got a slanted line, and this is my 2 points here. These are the scale lengths. Sorry, these are the offsets that were determined from our equation that we looked at before. But I just had to do the same equation twice for the different scale lengths for the high, the treble, and the bass here. So that's easy. And then here, I just created a point and a line between it. And I did that on the top plane. The next thing I did after that was to project them, project that sketch up onto this plane, and then did the similar sort of trick though with a mate connector, a sweep, boolean. This time I did a replace face so that it's nice and flush on the sides. That is a lot of it, but there's some preliminary work that happened back at the nut calculating. Before we didn't have to worry about that. We just did a nut straight across and then measured one distance from it. Not so easy this time, especially given that we want to be able to control who is the natural fret. So it's the same equation more or less to create a little offset from horizontal. Right? So this line here, which is the nut, is, if we look at that, which sketches that, there's a little bit of an offset here, this distance here, from this horizontal at the position of that first string, which I've just set as 1.5 off. Now, the TOF is the treble offset, and I'm dividing it by 2 because it's the same, on the other side, and treble offset. So it's this distance from the equivalent on the other side is the offset that we need. Now that is what we have to calculate here. And there's a series of variables, and they look like I've just typed them in, especially that one is suspiciously exactly 1 inch, but it's just the way that the equation worked out, I guess. Let's have a look at the variables and see what we did. So the baseline. Okay, so there's a couple of equations here. With this equation, you'll see is almost the same as the one we're doing for the offsets iterating over, but it is just using the actual natural fret number divided by 12, and we're just going straight to that one and finding this length. We do the same for the treble, and then we do some pretty fancy footwork in this variables here. So I'm setting the value of the bass offset on the treble offset, but there's an if statement in here. So let's have a look at how you do that inside a variable. So you can set a little expression which is going to evaluate to some kind of Boolean. So BLF is greater than TLF. If that is true, then it will use this value for BOF, for the bass offset. If it's false, it will use this value. And conversely, we do if TLF is greater than BLF, then we'll use 0 for T offset, or if it's not greater than BLF, it will use this equation. So you can do quite a bit in a feature script expression inside a variable. I'm not using custom features or anything like this. I'm just using what is actually a really, really simple construct, a really, really simple expression, but so powerful with the logic that you can encapsulate in here. I've seen JavaScript programs do all of this, but the cool thing is that we're not doing JavaScript, we're doing 3D CAD and everything that goes around it. Anyway, so we've got that offset, and that's the treble offset that I've used in this sketch here. I'm using the treble offset, again, divided by 2 because it's sort of mirrored across here. That solves the problem. And now we've got the nut at the right angle so that these next offsets will just proceed. Now, we can play with this. And again, this input to this was neutral fret number as a variable, right? As a configuration variable. So that means that we can play with it over here, and I can just type in a new number, say 9. And what you're going to find, as long as I got the math right, is that this purple fret, will now be the horizontal one. And if I want fret 7 to be horizontal, I just type 7 in here, wait for it to regenerate, magic numbers will update over here, and the 7th fret will now be horizontal or neutral. Now, you could actually go and put the nut to be horizontal just by setting that to 0. Let's see what happens here. And you'll see that, yes, the nut will go to neutral, but look what's happening down the bottom here. This is probably an inadvisable kind of situation. It might be very, very difficult to finger the notes up this end. So typically, we would probably go for 7 or 9, something like that. So the rest of it was just as we saw before. I haven't created the other configuration, which we could easily do. We could create a configuration, but in this case, I've actually just done some input, some configuration variables instead. So if I wanted to make it really extreme, like 27.5 inches on the base side, this is a pretty aggressive fanning. 27 inches on 25.5 on the treble side is more, or 25. Yeah, that was pretty super aggressive from before, but 25.5 to 27 is something that's fairly common, and we could now come in and start making trims of the fingerboard that's not needed, make some cool patterns, maybe some cool design down here, and do something nice on the nut end as well. Well, I hope that has been enjoyable. A bit of a late night session here. But feel free to ask any questions about this and anything else in Onshape.